Good morning, dear. Today we will talk about another particular line that can be drawn inside the triangle, which is height. Let's start by the definition. It's a segment issued from the vertex of a triangle perpendicular to the opposite side. When we talked about median, we said that it's segment issued from a vertex to the midpoint of the opposite side. That was about median. Now, the height, it's issued from vertex perpendicular to the opposite side. Okay, it's perpendicular. We can also call it an altitude or orthogonal projection. All these words mean the same. It's a segment issued from vertex perpendicular to the opposite side. Okay, and since it's perpendicular, so I can say it's the distance from the vertex to the base. Let's see an example. Here we have triangle ABC. AH is a segment issued from vertex A perpendicular to the opposite side. When I say it's perpendicular, so directly AH is the height or altitude or orthogonal projection. It's the height relative to BC. Okay, I don't care if H is midpoint of BC or not. Okay, I'm not talking about median. I can say that it's perpendicular, so it's height. Okay? Don't be confused, it's easy, but you have to concentrate. AH is the height relative to BC. Then AH here is perpendicular to BC at which point? At point H. So H is called the foot of perpendicular. Now, perpendicular, it means making a right angle. So AHC equal to AHB equal to 90 degrees, since perpendicular lines form a right angle. Don't forget, the point of intersection is called the foot of the perpendicular. Now, ABC is a triangle. AH is the height relative to BC. Let's find another height issued from another vertex. For example, CE. I have to draw here a segment issued from C perpendicular to EB. Then perpendicular to AB, sorry. CE is the height relative to AB and E is the foot of perpendicular. We can also say that CE is an altitude or orthogonal projection. Now, the third height is BF. It's issued from vertex B, perpendicular to the opposite side, which is AF. So, BF is perpendicular to AC at point F. Here we draw three heights inside a triangle. We noticed that they intersect at one common point. They are concurrent, okay, at point here, which we name it O. The intersection of the height is called the orthocenter. Orthocenter, it's the point of intersection of the heights in a triangle. Okay? Don't forget the intersection of median in a triangle. We call it centroid or center of gravity. Now the intersection of height is orthocenter. This height may lie inside or outside the triangle. How? Let's see. ABC is an acute triangle. AH is the height relative to BC. Now, this one, RST is an obtuse triangle since RST is an obtuse angle. RP is the height relative to ST. Okay, but why it's outside the triangle? Simply because from R, if I draw a segment here, I can't draw a perpendicular to ST and found it inside the triangle. So ST, we elongate this line to reach a point in which we can draw a perpendicular from RP. Okay? In an acute triangle, the orthocenter is always inside the triangle, while in an obtuse triangle, it's found outside the triangle. Okay? Let's talk about it again. Here we have a triangle A, B, C, and as we said before, the height should be perpendicular, drawn from a vertex to the opposite side. AD is the height relative to BC, and here CF is a height relative to AB, and BE is a height relative to AC. So I can clearly say that the heights are concurrent, they intersect at point O, then O is the orthocenter, and since it's an acute triangle, the orthocenter is found inside the triangle. Okay? In an obtuse triangle, for example RST, the orthocenter is always outside the triangle. The orthocenter is the point of intersection of the heights. Okay? Here, for example, we have triangle ABC. It's an obtuse triangle. Why? Because ABC is an obtuse angle. BE is the height drawn relative to AC. It's issued from vertex B. We can draw here the perpendicular or the height easily, so we draw it. This is the first height, BE. But to draw the height issued from A, the height should form a right angle, should be drawn perpendicular to the opposite side. The opposite side is BC, but we can't draw here from A to the opposite side and see that it's perpendicular. So definitely I have to elongate here BC and draw the perpendicular from A. These cases can be seen only in an obtuse triangle, okay, not in an acute one. And similarly from C, we draw the height relative to AB. How to find the intersection? Look, this one, CF, BE, and AD. To find the point of intersection, I have to elongate the three sides. So they intersect at point O. This O is the orthocenter. It's the intersection of heights. We found it outside the triangle because it's an obtuse triangle. Okay, please keep in your mind, when we talk about median, I told you that whatever the type of triangle is, the median is also found inside the triangle, is always found inside the triangle. But the height may be found inside the triangle if the triangle is acute, and outside the triangle if the triangle is obtuse. Now, how to draw a height? In an acute triangle, we use our set square. Okay, we intend here to draw a height issued from A. So, from A to BC, it's the height relative to BC, so put the set square on BC and draw the height issued from A. This is the height. Now the same, the height relative to AB, so put the set square on AB and draw the second height. Similarly, height relative to AC, put the set square on AC, one of its edges, and draw the height on the second edge, and this is the third height. These heights intersect at one point called orthocenter. Since it's the intersection of the height, it's called orthocenter, okay? Now, in an obtuse triangle, some side must be elongated to draw the height. This one is simple. From M, I have to draw the height, the perpendicular relative to Pn, and that's it. But to draw here, the height issued from P, to draw the perpendicular, it can be drawn inside the triangle, so simply elongate Mn and use your set square to draw the height issued from P perpendicular to Mn. This is the second height in the triangle. Similarly, to draw the height issued from N relative to PM, elongate PM and draw the height. Now, can they intersect here? Yes, I can elongate the heights so they intersect at a given point. This O is the orthocenter. It's the point of intersection of PM and M. Now, given the following figure, ABC, it has three acute angles, so it's an acute triangle. CF is it's drawn perpendicular to AB. It's issued from C perpendicular to AB, so it's a height relative to AB. Then CF is perpendicular to AB. Now, since BE perpendicular to AC, then BE is a height relative to AC. Now, what about AD? It's drawn perpendicular, so it's a height relative to BC. And what do you mean by height? We can clearly see that AD is perpendicular to BC. This is the sign that I use to abbreviate the perpendicular word. Now the three heights intersect at which point? Here, the purple, the green, and the blue, they intersect at point O. So they are concurrent. Okay, concurrent, I mean more than two sides intersecting at one point. So what do we call the point of intersection of the heights? It's called the orthocenter. Now it's your turn to solve these extra exercises and hand in your work and the assignment. Thank you for your attention.